المفروض تطلع لنا مسج هنا. أنا مشيت على المسج هنا إنه راح يسجل. طيب تمام. recording. You are recording now. شايفين؟ Now is okay. طيب تمام. And you can see the session, right? You can see the PowerPoint. طيب now, device selection for a small network. Usually, how we can select a device in a small network. Be careful. I'm talking about the small networks only here. This is our domain or our scope for the class today. Like the large network, a small network requires a planning and design to meet the user requirement. This is the most important goal. My network should meet my requirement. Planning will ensure that all the requirement, cost factors, we have a budget, and deployment options are given due consideration. So one of the first design consideration is the type of the intermediary devices to use to support the network. Intermediary devices, we're talking about switches and routers. So we have many factors must be taken into consideration when we select the network device. Cost. How the cost should be taken into consideration. For example, the cost of the switch or the router. How it will be determined by the capacity of that device. What I mean by capacity? The number of ports, the type of ports, the backplane speed. For example, some other factors also influencing the cost when we talk about the security technologies embedded in this device. Any advanced switching technology, it what influencing the cost of the device. Speed and type of ports or interfaces. So it's very important to select the type of the port and the speed on the router or the switch. It's very critical decision. For example, we may have a server with a port. The port operates at 10 gigabit per second. Expandability. Now be careful. I'm talking about the device as well. What does expandability means? Can we extend the device capability, not the network? I'm talking about a device here when I say expandability. In general, network devices can be classified into modulars or two types. Let me say fixed and modular physical configuration. It can available in fixed or modular configuration. Now, fixed means what? The device have a specific number and type of ports. It cannot be expanded. Now, modular device have expansion slots. Now, we have a PC, right? We can expand our PC capabilities by add an extra RAM. We can add external VGA. We can add external sound card, right? Same concepts. If the device is modular, physical device, we can, or we have the ability to add a new port, for example, by using some of the available slots. So a switch here can have additional ports, so we can add one high-speed link, for example. How we can decide it should be taken into consideration. All of these points. Operating system feature and services. Now, main or network devices, all the network devices must have operating system should or must or will have the ability to support the requirement of the organization. So Some of these requirements will be, for example, the DHCP, so it should be supported, security, quality of services, voice over internet protocol, voice over IP, NAT, in case we have an IPv6 and IPv4 network. So all of these factors should be taken into consideration when we simply want to select a device for the network. IP addressing now, it's very important. When implementing the network, create an IP address scheme and use it. It's the subnetting and somehow. We are talking about the subnetting here, but it should be created professionally. We need an IP address scheme here. So all the hosts and the devices within the network must have a unique address. Otherwise, they cannot communicate with each other locally. Full stop. We know this. So devices that will factor into the IP address scheme include the following. What are the devices that needs to be assigned an IP address? All end user devices. The number and the type of the connection, wired, wireless, remote, servers, peripheral devices, printer, security camera. It should be fall within this scheme. Intermediary devices, including the switches, access point, routers as well. So it's recommended that you plan, document and maintain IP addressing scheme. We are talking about the logical and the physical address scheme here, or topology. So the use of a planned IP address makes it easier to identify a type of the device to troubleshoot the problem. It helps me in case any problem occurs for the troubleshooting. As you see, every single step supporting a future service. Also, can we have a redundant devices in the small network? Yes. Why? To achieve a high reliability. What does that mean? My network is active 5/7. So in order to maintain a high degree of reliability, redundancy, تكرار هنا, is required in the network design. So the redundancy helps to eliminate a single points of failure. Simply main server is down, backup server is up. Main router is down, I have a backup router. Main switch is down, I have a backup switch. So redundancy can be accomplished by installing duplicate equipment. It can be also accomplished by supplying duplicate network links. Sometimes my connection to the internet is down. I have a backup one as well. So duplicate links for critical area. As you see here, redundant servers available in case the main or the master is down. Any other slave server can be up. Redundant switches we have here. Main is down. We have a backup. It's linked with all servers. They have a direct link between them. Usually we have a totally fully mesh here topology. Redundant router also are available in case one of the router fails. We have a backup router. Traffic management should be taken into consideration as well. Why? Main goal of the network design is to enhance the productivity of the employees and minimize the network downtime. Now, how we can improve the productivity? We need a reliable, fast network. We need to control the delay, minimize the delay. So the router and the switches in the small network should be configured to support real-time traffic. Traffic can be categorized according to its priority in other way. So voice and video will be a higher priority, is an appropriate manner relative to other data traffic. So a good network design will implement a quality of service. to support a real-time traffic. So priority queuing has 4 queues. High priority queue is always emptied first. The first in and out queue. The first out queue. It doesn't necessarily to be the first in a queue. So for example here, we have a traffic sent to the router without a priority. It contains an email request, instance messaging, FTP, web, any application with also a voice or real-time application, voice or video calls. So router will what? Will apply a quality of service. So the traffic will be sent to the backbone in order of the priority. So highest priority here for the voice. Number 2 is the email. So we're talking about the SMTP. We are sending an email here. Instance messaging, normal priority, FTP, lower priority. So we are giving an attention to the most important traffic according to its priority. How? Quality of service is the solution. Now, what about the application of the small network? So after you have set up your network, you still need a certain type of application and the protocols in order to work. The network is only as useful as applications that are on it. In general, we have 2 forms of programs or 2 types of network application. Network applications and application layer services. Application in general, a software program used to communicate over the network. Now, network applications are applications that implement application layer protocols and are able to communicate directly with the lower layer of the protocol stack. This is the main feature. We can call it a network-aware application. Network-aware, which means these applications implement the application layer protocol and can communicate directly with the lower protocol in the protocol stack. For a client web network application example. Now, the second type, let me say, of software programs, application layer services, simply not network aware. They cannot communicate with a lower proto layer on the stack. So they need an application. So they will simply just what? Generate the data. So for applications that are not network aware, they are not able to communicate directly with layer 2 after the application layer. The programs that interface with the network and prepare data for a transfer. So the program is what here? The application that will prepare the data and communicate with the layer before, not this type of software or application, sorry. Now, what we have here, quickly, a common list of protocols support an application in a small network. For example, network administrator will require access to the network device and services. So we have 2 common remote access solutions. We can use the telnet or we can use the secure cell as such. HTTP, Hypertext Transfer Protocol, or the Hypertext Transfer Protocol or the secure are used between a web client and web server. Simple Mail Transfer Protocol, Post Office Protocol, Internet Message Mail Access Protocol, sorry, not message, in order to send and receive an email between the client and the mail server. FTP, secure FTP, to upload or download. of files between a client and FTP server, DHCP used by the client in order to acquire an IP address, configuration information from the DHCP server if it's a stateful DHCP, DNS service, resolve the domain name to IP address, convert google.com to the IP address of this address. A quick note, like multiple network services in a single server. So the server might be FTP, SSH server, and email all in one in a single machine. Now, these protocols, the common protocols, containing a fundamental toolset of network professional, and all of them provide the common information defining the following. All of the protocols defining the following points. Any common protocol should define the processes on the client or the server, the end of the communication session, the type of the message, the format or the syntax of the messages, the meaning of informational fields. We know we will have a multiple fields. We need the meaning to know how the message will be sent, or how we are expecting a response. The interaction with the next lower layer. All of these defined by default at any common protocol. Within this list of protocols, we have talked about them many times. Because of this, I'm going a little bit fast. We have approximately, let me say, 45 slides to be covered. Many companies a secure version of the SSH, secure FTP, secure hypertext transfer protocol. Now, what about the voice and video application? Business today are increasingly using the IP telephony and streaming media to communicate with customer and business partner, as well as enable their employee to work remotely. So network administrator must ensure the proper equipment is installed in the network and that network devices are configured to ensure the priority of the quality of service. We are talking about this now because we have a real-time application. So, the factors that all small network administrator must consider when supporting real-time application are the following. Now, I need to make sure my network will support a real-time application. Make sure to take in your consideration the following factors. Infrastructure. Does it has the capacity and the capability to support a real-time application or not? Voice over IP protocol. It's simply a device converts analog telephone signal into a digital IP packets. So VoIP is typically less expensive than IP telephony, but at the cost of the quality and features. Now, small network, for example, can solve the IP problem here, or can use the voice and video over the IP by using some end-user applications, Skype, some, let me say, non-enterprise versions of any voice and video calling system. Now, IP telephony. It's an IP phone performs voice to IP conversation here. Voice to IP conversation with the use of dedicated server. We need dedicated server calls here or for call control and signaling. So in case we have a dedicated server, it will be handle the IP network or the IP telephony. Finally, real-time application. Network must support the quality of service mechanisms to minimize the delay, the latency. So in this case, real-time transport protocol and real-time transport control protocol to support the real-time application as a two supporting protocols for the real-time applications. So we done now with the small network. We done with the application used in the small network. Now our business is growing up, so our network will grow up as well. So we will talk about what scaling the network. So growth is a natural process for many small business, and their network must grow accordingly. Ideally, the network administrator has enough lead time to make intelligent decisions about the growing the network and alignment with a growth company. So in order to scale our network, make it larger, extend our network, several elements are required now. This is the important points in the slide. Network documentation about the physical and the logical topology. We talk about it in the beginning or in the module 16, sorry. Device inventory, what we have, a list of the devices that use or comprise the network. Budget, itemized IT budget, including fiscal, yearly budget. Traffic analysis, we need to know about the protocols, application, services, and their respective traffic requirements should be documented. And we can use some application tool to monitor our network, to capture data, to analyze our network. Now, these elements will be used to inform the decision making that accompanies the scaling of a small network. So, take all of these, understand, analyze all of these elements, we can make a decision to scale our network. Sometimes it can be simply that we will reallocate the server from a location or from a network to another network. Sometimes will be no. Additional devices should be added to scale our network. So it depends on the current situation. Now, why protocol analysis is very important? It's important to understand the type of the traffic that is crossing the network as well as the current flow, the performance of my network, which application consuming the traffic. So these are several network management tools that can be used for this purpose. To determine the traffic flow patterns, it's important to do the following. How we can do this? Capture the traffic by using a network during the peak utilization time to get a good representation of different traffic type. Perform the capture on the traffic network management and devices as some traffic will local to particular segments. This information gathered by the protocol analyzer is evaluated based on the source and the destination of the traffic, as well as the type of the traffic. The analysis can be used to make a decision how to manage the traffic more efficiently. Reallocate a service, reallocate a server, will improve the network performance. Sometimes optimizing the network performance will require a redesign. So how we can make a decision based on the traffic data and the analysis of the network performance and the traffic. As well, or as we have said, all network devices should include an operating system. So many operating systems provide built-in tools to display an information about the network utilization or such network utilization information. These tools can be used to capture a snapshot of information such as the following. We can take a data from our operating system, the OS version, CPU utilization, RAM, drive utilization, non-network application, network application. All of these data should be documented. So documenting a snapshot for employees in a network over a period of time is very to identify the evolving protocol requirement and associated traffic. For example, Windows 10 can provide me with this data. We can go to the setting, network and internet, data usage, network. So we'll have details about the application used in the network from the operating system. Is it useful? Yes. Can be used to improve the performance? Yes. Can be used to enhance the network as well. So we're now done with the data analysis, done with the size, done with the scaling. We need to verify the connectivity of our network devices. We need to know, is my network able to connect with any other device within the network or outside the network or not? So, whether your network is small and new, or you are scaling an existing network, you will always want to verify that your components are properly connected with other and to the internet. So how we can verify the connectivity? We can use the ping command. Ping command is available in most of the operating system and is the most effective way to quickly test network layer 3 connectivity between the source and the IP address. Ping 10.1.1.10. So we are here verifying the connectivity between PCA and BCB, which located on different network. So the uses the ICMP, Internet Message Control Message Protocol, ECO, and ICMP ECO reply to verify the connectivity. The generated request will be ICMP type 8 message, the response ICMP type 0. Now, as you see here, usually by default, the client or the device that wants to ping another device will generate 4 echo requests and expecting 4 echo responses. So the source here is 192.168.10.10, our destination 10.1.1.0. ICMP here is echo request, echo replies here. The PCB, the destination will be the source of the ping request. So on Windows 10, for example, host, the ping command sends 4 consecutive ICMP echo messages and expected 4 consecutive replies. Now, iOS or Internet Network operating system, Bing will send 5 echo messages and display an indicator for each of the Internet Control Message Protocol reply received. They will not display a full details, only indicator. So what's the indicator? What's the meaning of each indicator? This is the indicator. Here we are doing a ping, and these 5 symbols, they have a meaning. So now we'll see what are the main indicator can be listed by the iOS operating system. exclamation mark. Okay? Indicate Bing successfully sent and we have received a reply. So it validates a layer 3 connection between the source and the destination. Period. As you can see here, a period means the time expired, timeout, waiting for the reply message. This indicates that we have a connectivity problem here. Somewhere along the path, we don't know where, but in general, we have a connectivity problem. Indicates that router along the path responded with ICMP type 3, which means what? Destination unreachable, error message. So some possible reasons for this include the router do not know connection to the destination network, or it could not the host on the destination network. Now, is there any other indicators than these? Yes, we have a queue, and, but they are out of the scope of T216A. So we have only exclamation mark, period, uppercase U. So once we see this 5 times, meaning what? We have received 5 echo reply correctly. So as you see here, 5 is received, success rate 5 out of 5, round trip time is provided, average time is provided, the maximum time is provided in milliseconds. Now, how we can ping any device? Simply we type ping followed by the IP address we want to ping. Now, what? Or do we have a different or alternative option to the ping? Yes, we have extended ping. So Cisco iOS offers an extended mode of the ping. How the extended mode of the ping can be activated or used? Simply you will type ping without any IP address and will click enter. So extended ping is entered in the privileged exec mode by typing ping without any destination address. We'll then several prompts to customize the extended ping. For example, here, ping the protocol. What's the type of or the target IP address? We put the target. Repeat 5 times. Datagram size will not change any input here. So simply enter, enter, enter. Extended command, yes. Now, source address of the interface. Now, this address, the source address will be the router, this interface. So we can control the source of the ping by using the extended commands. We can change the source of the echo request. So this is the source. Source will send 5 ICMP echo to the destination address with the time out is 2 seconds here, the timeout. We have received 5 exclamation. 5 successfully replies received with the details about it. So either the normal ping or the extended. Extended simply we can control some parameters within the ping. Even we can change the source of the request. So as you see here, now we done with the ping. Now let us go to the trace route. Now what's the difference between ping and the trace route? Now we have ping a device on the network, the device is unreachable. We said that when we do not receive a reply, it means that we have a problem along the path, but we don't know where is the problem. So in order to test the path, we can use the trace route. If you remember, the trace route provides me with a number of hubs from the source to the destination. Trace route table. So the ping command is useful to quickly determine if there is a layer 3 connectivity problem or not. However, it does not identify where the problem is located along the path. So trace route can help the local layer 3 problem, can help locate, layer 3 problem area in the network. Why? Trace will return a list of hubs as the packets is routed through. So how the syntax of the trace route or the trace command varies between the operating system. If we're using the Windows, we'll write trace it, followed by the IP address. When we talk about the Cisco devices, we'll use a trace route command followed by the destination address. So, following sample is the output of the tracert command on Windows 10. We can interrupt or abort the output by using Ctrl+C or by pressing Ctrl+C. Now, according to this example, according to this output, tracert 10.1.1.10. So for the output, it's showing that we have only one response from the gateway of R1, which means the connection between the device and R1 is successful. Outside that, we have a problem. R2 and R3. How I know this? From this output. So only successful response was from gateway on R1, trace requests to the next hub timeout as indicated by stars. The stars here means what? Request timeout, meaning that the next hub router did not respond or there is a failure in the network path. So in this example, it appears that we have a problem between what? R1 and R2. Why? Because the PC connected R1 or the trace show me that R1 gateway response without any problem. After that, we did not get any response because of the star sample. So it's most commonly the problem is here between R1 and R2. So when we see the asterisk here, it means what? We have a connection problem. There is no reply receipts. One more example, we are using the trace route. So what's the difference between the output in the left side and the output at the right side? On the left side, trace validate that it could successfully reach PCB. So here we have receipts, the response without any problem. As you see, number 3 is the destination address. So we validate the connectivity and host B is reachable. While on the right side, the host was not available. And the output shows statistics where replies timeout indicate there is a potential problem. So we have a connection until 209, 156, 200, 203. So I think let us assume it's router. So the connection to router 2 without any problem. So we can use Ctrl+Shift+6 to interrupt also the trace route output in Cisco. So what's the difference between ping and connectivity? Ping will be used to verify that we have a connection between the source and the destination. In case there is no echo reply, we have a connectivity problem. But in order to determine or verify the connection, the location or approximate location, we should use the trace route to monitor the number of hubs, so we can determine the location of the connectivity problem in case we have a problem at the trace route output. Now, do we have extended trace route? Yes, like the extended ping command, there is also extended trace route command. It allows the administrator to adjust the parameter related to the command operation. Windows tracer command also allows the input of several parameters through options in the command line. However, it's not guided like extended trace route. iOS command, the following output display the available option for Windows tracer commands. As you see, we have multiple options can be used in case we are going to implement the extended trace route, not the normal trace route. Also, extended trace route can be used for Cisco, same like the ping. We enter a trace route without a destination address, without an IP address. How data can be changed or information according to the input data. So here we have set the target address, we have set the source address. Trace route will be started from where? No need to start from the PC, we start directly from the out interface of the router, from the router interface. So as you see, first connectivity is successful, second okay, but between R2, let me say, or R3 and PC, we have a problem. Or the problem is between R2 and R3 according to this. If the IP address is R2, so the problem is located here. If we have a fully IP address, we can determine from this where is the problem. So Cisco extended trace route option enables the user to create a special type of a trace by adjusting a parameter related to the command operation. Extended trace route is entered at the privileged exec mode by typing a trace out without a destination address. iOS will guide you through the command option by presenting a number of prompts related to the setting of all different parameters. So either we change the parameter setting. If we do not want to change any setting here, we simply press enter. So we just here set the target and the source. Finally, network baseline. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. A document reference data in other way. One method of starting the baseline is to copy and paste the result from an executed ping, traced, or any relevant information in a text file. Text file data can be timestamped with the date and saved into archive for later retrieval and comparison. So all our verification actions and copied in a text file based on the time and the period. So among the time to consider, or among times to consider, are error messages and responses time from the host to host. So corporate network should have extensive baseline files, more extensive than. So professional grade software tools are available for storing and maintaining the baseline information. Simply baseline, any test, any activity should be copied, its output, its details should be stored for future investigation or reference use. That's all. طيب, now let us try. We still have a little bit time. نكمل بس شوي. المشكلة ما كملنا. طيب, نكمل شوي بس. IP configuration in Windows. Now we know we can use the network and sharing center to configure an IP device or IP configure the device by using the interface. Most important configuration for any device, we're talking about the IP address, mask, router, DNS IP as well. So we can use the IP config command at the command line of Windows computer to check all the configuration. How we can list on the device by using a Windows IP config all commands. It can be issued to see the MAC address, the numbers of details regarding to the layer 3 addressing of the device. We can see the IP address, subnet, gateway, MAC address, and so on. Now, in case the host is connected to the DHCP network as a DHCP client, we can renew also our IPv4 address. So how the IP address can be renewed? We can use IP/release command. So release the current IP address to the DHCP server. Then we will create or requesting a new IP address. So we can use ipconfig/renew commands. DNS clients service on Windows PC also optimizes the performance of the DNS name resolution by storing the previously resolved names in memory. So by using ipconfig/display DNS name command, it will display all the cached DNS entries in Windows computer system. So we can see all the resolved names stored on the cache of the DNS server by issuing this command. Now, for the configuration, verifying the IP setting using a graphical user interface in Linux machine will differ depends on the Linux distribution and the desktop interface. On the command line, we simply will use the ifconfig, not the ipconfig as you see here. So ifconfig commands here can be used to display the status of the currently device interface and the IP configuration. We have the IP address, broadcast address, mask address, IP version 6 address. So simply the ipconfig command details, but on different operating system, on different format. So the Linux IP address command, so we can use ifconfig command to display the status of the currently active interfaces and their is used to display the address and their properties. It can also be used to add or delete IP address. One more comment, output depends on the Linux distribution. Now, what about the configuration on the Mac? How we can check the configuration by using the GUI, the graphical user interface. When we talk about the Mac host, open a network, preferences, advanced, you will get the IP address information. A command line way, we can use the ifconfig like Unix in order to verify the interface IP configuration at the command line. Other useful Mac OS command to verify the host IP setting include network setup minus, as you see here, list all network services. And also we can use network setup minus get info and what's the network service name. So we have here listed all the services. We have Wi-Fi, Bluetooth, simply. So what we did here, network setup minus get info about the Wi-Fi network. So we have an IP address, subnet mask, router, Wi-Fi ID. There is no IPv6 here is used or configured. So simply we can check or listing or revealing the configuration either by using the ifconfig, ipconfig. We can use the GUI. Now, what about the ARP command? ARP command is executed from Windows, Linux, Mac command prompt. The command lists all the devices currently in the ARP cache of the host, the IP address and the MAC. You remember why we are using the ARP of the recently connected devices. So ARP-A command displays the known IP address and the MAC address pendings. ARP cache only display information from the device that has been or have been recently accessed. As a device, all the devices that was accessed recently by me, all IP address and its related MAC address can be listed by using ARP-A command. To ensure the ARP cache, ping the device so that it will have an entry in the ARP table. Any device pinged, it will be added as an entry to the ARP table. The cache also can be by using netsh interface IP delete ARP cache command. In the event the network administrator wants to repopulate the cache with updated information. So we can, by performing this command, delete all the entries from the ARP cache. But you sometimes may need administrator access on the host to be able to perform this command. Otherwise, you will receive a permission restriction commands. طيب, I'm going to stop here. So يعني do not طيب, it's not too much ولكن نشوف الآن. لحظة.